The source identifies the company as
Powered by
SV
Riverside
Engineers in
FM.
India.
Okay, straightforward enough. Location pinned.
Right, operating out of India.
Yeah.
That's clear. And it also mentions their brand name,
Which is,
SV Engineers brand name, SV Blowers. So SV Blowers is what they're known as, presumably.
yeah, SV Blowers. That gives us the name and the base,
Yeah.
India. And, operating out of India isn't just a location tag. It tells you something about the market context.
How so?
Well, it's a huge dynamic industrializing economy. So a
Yeah.
company like SV Blowers, they'd be shaped by that environment. Okay, let's think about something for a second. Those invisible forces,
Yeah.
in industry, not just the huge machines, but the subtle stuff, like the air itself keeping things running. Today, we're taking a deep dive into something that sounds maybe a bit niche, but is actually critical: aeration blowers. Specifically, twin lobe roots air blowers. And our mission really is to dig into the sources you shared, find those key insights on smart installation and maintenance, and basically translate that technical stuff into knowledge you can actually use.
Yeah, and it's kind of amazing how central these machines turn out to be. You might think big industrial plants, wastewater treatment, and yes, that's huge. But they're also vital in places you might not expect, like, say, a delicate shrimp hatchery. And understanding how to install them right, how to care for them, it's not just about saving a few quid on repairs. It can literally prevent a complete operational shutdown, which for some businesses is, well, devastating.
Absolutely. And I think you're going to have some real aha moments during this dive. like
Yeah.
Learning how just a small bend in a pipe can actually affect the health of tiny microorganisms.
We're finding out that a lot of the common ideas about why these blowers fail are, well, frankly, myths. Myths that cost money and cause a lot of headaches. Okay, so let's start with the basics then. What exactly are these positive displacement blowers, these PD blowers, specifically the twin and trilobe roots type? What's special about them? Why are they the go-to for that continuous air at sort of moderate pressures, like 0.1 to 1 kg mamma juices?
Right. The key thing is how they work. They deliver a consistent volume of air. Constant volume. That means the amount of air pushed through stays pretty much the same, even if the pressure in the system downstream changes a bit.
Okay, constant volume, regardless of pressure.
Exactly. And that is why they're indispensable in places like sewage treatment plants, STPs, and effluent treatment plants, ETPs. Because in those systems, you need that absolutely steady, reliable supply of oxygen. It feeds the aerobic bacteria, the little microbes doing all the hard work, breaking down waste.
Ergopic workhorses, yeah.
Precisely. And if that oxygen supply falters,
Yeah.
the whole biological treatment process it grinds to a halt. It's interesting how versatile they are, though. I was looking through the sources, and beyond wastewater, the list is quite surprising. You've got aquaculture, keeping oxygen levels right in fish ponds, shrimp ponds,
Yeah,
which is obviously life or death for the stock.
critical, yeah.
Then there's pneumatic conveying, moving stuff like cement or flour or fly ash around factories,
Using air to push materials.
and molasses aeration in sugar production, fermentation in food processing, even electroplating, apparently, for getting a uniform coating. They're kind of hidden everywhere.
And that brings us back to those microorganisms we mentioned. This is really important and often missed. See, these microbes, they have a sweet spot. They thrive best at moderate pressures, think 0.1 up to maybe 0.3 kilojoule meter erosion.
Okay.
But when that discharge pressure starts climbing higher, especially once it gets over 0.4 kilojoule meter of Wiedestyrerosia, the air itself heats up significantly.
The compression heats the air.
Exactly. And that hot, high-pressure air, it can actually harm or even kill those beneficial bacteria.
So you directly hurt the process efficiency.
Directly. If your microbial workforce is struggling or dying off, your whole system performance tanks. It's a very direct link, and it's surprisingly sensitive.
Okay. So they're vital, but clearly things can go wrong.
Yeah.
And the sources really point to one main issue, the most common, most costly problem: excessive back pressure. They call it the silent killer, which sounds dramatic, but I guess it makes sense if it leads to overheating without obvious warning signs.
It really is a silent killer, and it sets off this chain reaction. Too much back pressure forces the blower to work much harder than it's designed to.
Right.
That makes the whole blower casing get hot, and crucially, the lubricating oil inside gets hot too. And what happens when oil gets too hot? Its viscosity drops, it thins out.
It doesn't lubricate as
Precisely. It can't maintain that essential protective film between the moving parts. So you start getting inadequate lubrication. Oil might start leaking past seals because it's thinner. Seals fail. And then the critical internal parts, the gears, the bearings, the shafts, they start wearing down rapidly because of metal on metal contact. Yeah. And the result? You're constantly replacing expensive spares. Maintenance costs go through the roof. And everyone gets frustrated, often blaming the machine itself or the Suvis guys. When the root cause is often hidden, it's that back pressure issue that started the whole cascade.
And there's a specific number mentioned, isn't there? A kind of threshold?
Yes, the sources consistently highlight that trouble often starts brewing when the discharge pressure gets above 0.4 kilojoules per meter point.
0.4. Okay.
That's a really key figure to watch, especially if your blower's maximum rating is, say, 0.7 kilojoules per meter point, or maybe even lower. It's like a warning zone.
All right. So if back pressure and overheating are the big enemies, how do we fight back proactively? Let's shift to the do's. The essential steps during installation, during operation. What's the first line of defense look like?
It absolutely starts with the initial setup. Proper erection is key. First off, something simple but often skipped, the free rotation check. Before you even couple the motor, just turn the blower shaft by hand. Does it move smoothly? Or does it bind? This simple check can save you so much trouble later.
Good point. What else?
Second, motor rotation direction. Double, triple check it. Blowers have a specific direction, usually marked with an arrow. Get the motor spinning the wrong way, and you can cause serious internal damage almost instantly.
Okay, direction matters.
Got it. Third, lubrication. Non-negotiable. Use the recommended grade oil, often SAE 90 or 140, and keep that level right between the MIN and max marks on the sight glass. Not too low, not too high.
Right.
And fourth, piping design. This is huge. The discharge pipe has to be the same diameter as the blower outlet, or preferably even larger, never smaller right at the outlet. And make sure the discharge point is open or properly vented so the air can get out without being choked off.
You mentioned valves earlier too, the NRV and PRV.
Mm-hmm.
Why are they so critical? What's the risk if someone, maybe trying to save costs, skips them?
The valves. Okay, the non-return valve, or NRV. That goes on the discharge line. Its job is simple. When the blower stops, it prevents air, potentially water or material if it's that kind of system, from flowing backwards into the blower.
So it protects the blower from backflow damage.
Exactly. Without it, you could suck stuff back in or just put reverse stress on the lobes. Bad news. Then there's the pressure relief valve, or PRV. This is your safety valve. You set it to open just slightly below the blower's maximum safe operating pressure.
So something blocks the line or pressure spikes?
The PRV opens and vents the excess pressure, protecting the blower, the pipes, even the motor from catastrophic failure. It's like a fuse. Skipping it is, well, incredibly risky.
Makes sense.
And don't forget the foundation. A solid, level, vibration-free base for both the blower and motor is really important for smooth running and long life. Oh, and good quality suction silencers and air filters. Keep that dust and debris out from the start.
Okay, so those are the crucial do's. But sometimes knowing what not to do is just as important, maybe even more so. What are the common mistakes, the don'ts that people make, the things that seem small but lead to big problems?
Right, the traps to avoid. And some of these are surprisingly common. Number one, a big one, installation location. Never install the blower below the level of the tank or process it's feeding air into, especially in aeration.
Why not?
Because the static head of the liquid above the discharge point creates instant, constant back pressure on the blower, even when it's just sitting there. It guarantees higher operating temps, more noise, oil leaks, and just drastically shortens the blower's life. It's a fundamental no-no.
Okay, keep it above the tank level. Got it.
Second, back to piping design. Don't reduce the pipe diameter right after the blower discharge. Maintain the size or go bigger, and avoid sharp bends or too many bends close to the blower. Every bend adds resistance, adds back pressure, adds heat.
Right, keep the flow smooth.
And that's specific rule for common headers. If you have two blowers feeding one pipe, that main header pipe needs to be double the cross-sectional area of a single blower outlet. Not just double the diameter, double the area.
Ah, that's a key detail. So it can handle the combined flow without choking.
Exactly. Otherwise, they just fight each other. Third, and this should be obvious but needs saying, lubrication. Never run the blower without the correct gear oil, not even for a test spin, not for a minute. It will cause immediate catastrophic damage to the gears and bearings.
Instant seizure.
Pretty much. And finally, motor control. Don't run it in reverse. Don't use the wrong motor. Check the horsepower and RPM requirements carefully, and never operate the blower with the main delivery valve fully closed. That deadheads the blower, pressure spikes instantly, and you risk severe damage to everything.
That really underscores the need for careful handling, which leads to a safety point, right? These are powerful machines.
Absolutely.
So the source is emphasized. Never try to work on the blower, service it, open it up while it's running. Seems obvious, but
You'd be surprised.
always switch off the power completely, lock it out, tag it out if you have procedures for that. Let it cool down properly, they get hot.
Very hot sometimes.
And don't try to bodge it without the right tools. If you're unsure about anything, the message is clear. Call in the professionals. Don't risk injury or further damage.
Okay, so we know the pitfalls, we know the basics of good setup, but what about going beyond that? Are there smarter ways, maybe using technology, to extend life and prevent that overheating issue? You mentioned something about smart controls earlier.
Yes, this is where things get interesting, moving towards proactive protection. A lot of the wear and tear comes from relentless continuous operation under load and heat. So a really effective strategy, especially if you have a duty standby setup with 2 blowers, is a temperature and timer-based control system.
How does that work?
You use a PLC, a programmable logic controller, basically the small industrial computer. You program it to run, say, blower A for a set period, maybe 1 hour, 2 hours, 4, 8 hours, whatever suits the process.
Okay, a timed cycle. Right, but here's the clever part. You also install a temperature sensor on the blower casing. The PLC monitors that temperature. If blower A hits a preset limit, maybe 50 degrees Celsius, or if its run timer expires, it automatically shuts down blower A and starts up blower B. It's an auto changeover.
Ah, so blower A gets a break.
Exactly. It gets crucial rest time. This allows it to cool down completely, relieving that thermal stress. Then blower B runs its cycle and the system switches back. This simple alternation dramatically extends the life of both blowers. It prevents them from constantly running hot and stressed.
That sounds like a really smart investment, shifting from hoping it doesn't break to actively managing its workload.
It really is. It moves you towards predictive, condition-based maintenance rather than just waiting for failure.
So bringing it all together for the folks managing these systems or just curious about what good practice looks like, what's a reasonable maintenance schedule, what should people be checking, and how often?
Okay, a good routine is key. Think of it in layers. Daily, just a quick walk around. Listen for any weird noises, unusual vibrations. Glance at the oil level in the sight glass. Take seconds.
Okay, simple checks.
Weekly. Take a closer look at the air filter. Is it getting clogged? Clean or replace it if needed. Check the foundation bolts are snug. Monthly. Now you get a bit more involved. Check the lubricant condition, maybe top it up if needed. Log the operating temperature and pressure, look for trends. Check the tension on the drive belts if it uses them.
Right, tracking the vital signs.
Quarterly. Maybe time for a pressure drop analysis across the filter and silencer. Inspect any minor wear parts. And then annually. Depending on usage and conditions, this might be the time for a more thorough service, possibly an overhaul, inspecting oil seals, bearings, gears more closely, maybe replacing them proactively based on hours run.
So it's a rhythm, from daily awareness to deeper annual checks.
Exactly. Sticking to a schedule like that is really the best way to ensure reliability, catch problems early, and get the maximum life and efficiency out of the equipment. It prevents those sudden, unexpected, and often costly failures. So when you pull all this together, what we've really seen is that focusing on these, seemingly basic but actually critical details of installation and maintenance for these blowers, it pays off massively. You're not just stopping breakdowns, you're genuinely looking at potential energy savings, way fewer service calls, and just a much, much longer useful life for the equipment. And that applies whether it's a huge municipal plant or, that small fish farm we talked about. It's about being proactive.
Yeah, this whole deep dive, it really makes you think, doesn't it? It's a great example. Where else, maybe in your own work, your own industry, or even just how you maintain things at home, where else could applying these same principles, really understanding the why behind the how, focusing on smart setup, paying attention to those details make a real difference? Maybe here's a final thought to leave you with as we wrap up. What other crucial bits of kit may be hidden away in our infrastructure and our technology? What other essential components might be failing early, costing us time and money, just because we haven't really stopped to think about the best way to install them and look after them properly? Makes you wonder.